Welcome. Today we take few more problems on the chapter increasing and decreasing function. Take the first problem as the function f(x) is equal to 3 sin x plus 2 cos x by sin x plus cos x is increasing, rather strictly increasing in options minus pi by 3, pi by 2, x greater than 0, all real value of x, for no value of x. So this case also, the problem is very straightforward. One function is given, we have to find where the function is strictly increasing. Function is this, we have to differentiate that first. This can be simplified as 2 into sin x plus cos x plus sin x by sin x plus cos x. This part, it is equal to 2, this by that, plus sin x by sin x plus cos x. Therefore, f dash x is equal to, its derivative is 0, derivative of that cos x into denominator minus sin x into derivative of the denominator cos x minus sin x by sin x plus cos x. Now this one is sin x cos x, this is minus sin x cos x, cancel. So cos square x plus sin square x by sin x plus cos x, so that it is 1 by a whole square, its whole square. Now it is clear that denominator is positive and numerator is simply 1. So it is positive for all real value of x. So this is positive for all real value of x. That is, this option is correct. Next. Second one, in 0 less than x less than pi by 2, fx is equal to sin x by x is first option strictly, this is strictly increasing function. Second one is decreasing function. Third one is increasing function. And fourth option is strictly decreasing function. Okay, that's all. So in this problem, one function is given and one interval is given. We have to find in that interval the function is whether strictly increasing, only increasing, decreasing, and strictly decreasing. We have to find it. So for that purpose, we have to find the derivative. First, find derivative f dash x is equal to, it is u by v, numerator by denominator. So x into cos x minus sin x into its derivative is 1 by x square. Now derived function is that x square is ever positive in that interval, and it is not clear to us now whether in that interval x cos x minus sin x, whether it is positive or negative, it is not at all clear. For that purpose, we have to take gx as x cos x minus sin x. Now try to find whether this function is positive or negative. For that purpose, differentiate g dash x is equal to cos x, x into minus sin x, minus derivative of that is cos x. It is equal to cos x cancels minus x sin x. Now in that interval, x positive, this is positive, and sin x also positive in that interval because the interval is first quadrant. This is positive, so this one is positive. Ultimately, it is negative in that. So we say that gx is this, g dash x is negative. Therefore, gx, the function gx, is decreasing function. In that interval. Therefore, for x greater than 0, gx is less than g0. But g0, it is 0 for that part and 0 for this part. So this is simply 0. That is, gx is less than 0. Gx is nothing but numerator of f dash x. So this part is negative. So f dash x is negative. If f dash x is negative, then we say fx is negative less than 0, not less than or equal to 0, less than 0. So it is strictly decreasing in that interval. Okay, next. So next problem is for fx is equal to x e to the power 1 minus x. Which one is true? First option is increasing in 0 to infinity, strictly decreasing in 1 to infinity, decreasing in 0 to 2, and strictly increasing in half to 2. Now, here also it is very straight cut formula. Some function, this function is given, and we have to identify which statement is correct, that this function is increasing in that interval, strictly decreasing in, and so on. For that purpose, we have to find derivative. F dash x is equal to, it is product of 2, so 1 into e to the power 1 minus x, then next x into e to the power 1 minus x, and derivative of that is minus 1. That's why it is negative. So that e to the power 1 minus x can be taken common, 1 minus x. Now, this is the derived function. E to the power 1 minus x, it is ever positive. This one in finite range, this is ever positive. And this is negative if value of x is greater than 1. So this is strictly negative in 1 to infinity. So this function x into e to the power 1 minus x, it is strictly decreasing in that range. That is strictly decreasing in that range. So it is correct option. Now, the next problem is fx is equal to 3 into mod of x minus 3 plus 4 of x minus 4. So fx is equal to that. This function decreases in, 4 options are there: 0 less than x less than 3, x greater than 3, 3 less than x less than 5, and x less than 4. Now the problem is function, the function is in terms of mod value, and we have to identify in which range the function is decreasing, in which range this function is decreasing. Let us simplify the function. Fx actually is equal to, actually the function it becomes 0 at x is equal to 3, and this becomes at x is equal to 4. Let us study the function for 3 cases. One is x less than 3, other is x greater than 4, and third one is in between 3 and 4. When x is less than 3, this is negative, this is also negative. So in that case, 3 into function is 3 into 3 minus x plus 4 into 4 minus x. That is, it is equal to 9 plus 16, 25 minus 7x in x less than 0, x less than 3. Now, secondly, we study the case between when value of x is between 3 to 4. X is more than 3 but less than 4. In that case, it is more than 3, so that part is positive. So it is equal to 3 into x minus 3. And because x is now greater than 3 but less than 4, so this part is negative. So plus 4 into 4 minus x. This is after simplification, it is 16 minus 9. That is 16 minus 9 is 7, and minus 3x plus 3x minus 4x, that is minus x in 0, not 0, in 3 less than x less than 4. Now consider the case when x is greater than 4. If x is greater than 4, this is positive, this is also positive. So functional value is x minus 3 plus 4 into x minus 4. So that it is equal to 7x, 3x plus 4x, minus 9 minus 16. Now we have to identify where this function is strictly decreasing. F dash x is equal to that in that range. It is minus 7 in less than 3. Let us see in that range between 3 and 4, this function is that. Therefore, each derivative is 0 minus 1 in, and for other one, that is x greater than 4, in that range, derivative is 7 minus 0. So we see that the function, derivative of the function is negative when x less than 3, when it is again negative in that range 3 to 4, and positive is over there. So the function actually f dash x is negative when x is less than 4. Therefore, the function decreases in the interval when x less than 4. Fourth option is correct. Our next problem is, let us take the next problem. Fx is equal to e to the power ax plus e to the power minus ax. A is given as positive, is increasing in four options: x less than 0, x greater than minus 1, x less than -1 and x greater than 0. That problem was given in WB JEE 08. The previous problem, mod problem, that problem also given in West Bengal Joint Entrance Examination in the year 2009. I forgot to mention. This the exponential function fx is equal to e to the power x plus e to the power minus x, and a is positive. Mind that a is positive, that a. Now, to identify the region where the function is increasing. For that purpose, we have to differentiate f dash x is equal to a into e to the power ax minus a into e to the power minus ax, because its derivative is minus a. It is equal to a into e to the power ax minus e to the power minus ax, that is 1 upon e to the power ax, is equal to a into e to the power 2ax minus 1 divided by e to the power ax. Now, to identify whether it is positive or negative, a is positive, that part is positive. E to the power ax, it is ever positive. So this is also positive, this is positive. And numerator will be positive if e to the power 2ax minus 1 is positive. That is when e to the power 2ax is greater than 1. Now you see, this is equal to 1 if x is 0. When x is greater than 0, then this is greater than 1. So in that case, the whole thing is positive if x is positive. So the function is strictly increasing in that range when x is positive. Next, a function fx is such that fx is equal to 0 if rather at x is equal to 0, and it is equal to fx is equal to x minus 3 if x is greater than 0. Then which one is true? Number one, increasing at x is equal to 0, strictly increasing for x greater than 0. Next, strictly decreasing at x is equal to 0 and decreasing in less than 3. So then This problem also given in the year West Bengal Joint Entrance Board in the year 2011. Now, a problem, in that problem, function is given for two intervals, fx is equal to 0, at x is equal to 0, and when x greater than 0, it is x minus 3. So, fx, f dash x, is equal to 0 at x is equal to 0 is equal to 1 at x greater for x greater than 0. So, f dash x derivative is positive for that case, x greater than 0, and 0 for that case. So, the function is strictly increasing for x greater than 0. So, this answer is all right. Next. So that the function hx is equal to fx minus fx whole square plus fx whole cube is increasing if fx is increasing and hx is decreasing if fx is decreasing. That problem was given in IIT entrance examination in the year 98. Okay. This is a very unique type problem. A function is expressed in terms of the other function fx, and we have to prove that hx, that function, will be increasing if fx is increasing, and this function is decreasing if fx is decreasing. For that purpose, let us find derivative h dash x is equal to f dash x minus 3 times fx whole square into f dash x plus, this is not both fx whole cube. First one is fx whole square. This is whole cube. So this is not true. Its derivative is 2 into fx to the power 1 into f dash x plus 3 into fx whole square into f dash x. F dash x can be taken common. 1 minus 2 fx plus 3 fx whole square into f dash x. Oh, f dash x already taken common. So that f dash x. Now we have to find its sign, positive or negative. Take 3 common. this become fx whole square minus this become 2 by 3 fx plus 1 by 3. Let us try to make it sum or difference of two perfect squares. 3 f dash x into fx whole square minus 2 into 1/3 fx plus 1 by 9 minus 1 by 3. Oh, actually I have taken this 1 by 9 extra, excess, to make it a perfect square up to this. So we have to adjust it. It is 1 by 3 minus 1 by 9. So that it is equal to 3 into f dash x up to this. It is fx minus 1 by 3 whole square, and they together is 3 minus 1, that is plus 2 by 9 positive. So we see this is positive for all values of x, and this is ever positive. So this is, the whole thing is positive if this is positive if f dash x is positive. From first consideration, if this is positive, h dash x is positive. So h dash x is increasing if f dash x is increasing. So increases, sorry, excuse me. So hx is increasing if fx is increasing. First part is proved. And you see this is positive, and if this is negative, then h dash x is negative. So this, if this is negative, if f dash x is negative, that is h dash x is negative, means h dash x is decreasing when f dash x is less than 0, that is f dash x is decreasing. So this part also proved that hx is decreasing if fx is decreasing. This is also very interesting and important problem. Next. Now, our next problem is the cost of production of x units of a good is y. Cost of production of a good, x units of good is y, cost production. Rate of change of y per unit of x, rate of change of y, that is dy per unit change of x, that is dy dx, it is known as marginal cost. If y is equal to 3x into 8 minus x by x plus 1 plus 14, then show that marginal cost will continuously decrease if x is increasing, x, and given that x is greater than 2, if this increasing. First of all, two informations are given. One is one good is there and cost of production of X unit of that good is Y, and derivative, that is marginal cost, its definition is the rate of change of Y per unit X, that is dy dx is marginal cost, it is given. Y is also given, Y is equal to that. Then we have to show that marginal cost will decrease continuously whenever X increases, but given that X is greater than 2. X is greater than 2, it is given, and when X increases, then marginal cost, that is dy dx, will be decreasing. For that purpose, we have to find differentiation of Y is equal to, it is product of two factors, 3 into 1 into that plus X into derivative of that minus 1 into X plus 1 minus 8 minus X into derivative of that is 1 by X plus 1 whole square, and derivative of that part is 0. So that it is equal to 3 into plus, this is minus X, this is plus X, cancels, minus 1 minus 8, so it is minus 9x, minus 1 minus 8, 9x by x plus 1 whole square is equal to 3 into, now simplify, LCM is x plus 1 whole square, so 8 minus x into, into x plus 1 minus 9x is equal to 3 into it is 8x constant term is actually 8 minus x into x plus 1, so that 3 into 8x plus 8 minus x square minus x minus 9x, two terms will be negative. It is 8x plus 8 minus x square minus x minus 9x divided by x plus 1 whole square is equal to 3 into minus x square minus 10x plus 8. What to prove? Just 1 minute. Marginal cost will continuously decrease if number of unit is greater than 2, x plus 1 whole square. Oh, that is just 1 minute. I think I somewhere mistaken. Plus x into minus 1 into x plus 1 minus 8 minus x into 1 by this whole square. This is minus 1 minus 9x minus x plus x. That is also okay. So x plus 1 whole square, 8 minus x into x plus 1 minus 9x. So that 8x plus 8 minus x square minus x minus 9x. So that minus x square minus 10x No, minus x square minus plus 8 minus 1 minus 2x plus 2 plus 8 divided by x plus 1 whole square is equal to 3 into, if I take minus 1 from there, it is minus x plus 1 whole square plus 9. I have added 1 and subtract 1 divided by x plus 1 whole square. Now you see, this is positive, this is positive. 3 by x plus 1 whole square, it is positive. And here is 9 minus x plus 1 whole square. Now x is number of units produced. So it must be integer. Given that when x is greater than 2, when x is greater than 2 means x is either 3 or 4 or 5, it starts from 3. So when x is greater than 2, so it is 3, it is positive. X, for x greater than 2, so it is positive. This is positive, then this is also positive. So dy dx, that is marginal cost, is positive. Hence, we have to prove that when x is greater than 2, when x increases, base value is x greater than 2, and x increases, then dy dx is positive. That is, marginal cost is equal. Okay, thank you. Let us stop today.